In this presentation, a comminuted fracture of the lateral body of the mandible will be treated with load-bearing osteosynthesis using a 2.4 locking reconstruction plate after simplification with 2.0 adaptation plates. The objectives of the exercise are to understand the basic principles of the locking reconstruction plate and the correct application of the reconstruction plate and the supporting adaptation plates. The locking reconstruction plate combines all the advantages of a standard reconstruction plate with the locking principle. The thread in the plate holes provides rigid anchorage for the 2.4 mm locking screw. This construction acts as an internal fixator. 3 mm screws are also available. The conventional MF Cortex screw can also be used with this plate. Wide angulation of the screw is possible, which in certain clinical situations can be an advantage. Other advantages of the locking principle are: the plate needs only limited adaptation, it exerts no pressure on the bone, and the risk of screws loosening is reduced. In the clinical setting, a submandibular approach is used. Care is taken to avoid the marginal mandibular branch of the facial nerve. The entire fracture is exposed, so that the 2.4 locking reconstruction plate can be anchored by at least 3 screws on either side of the comminuted area. The comminuted area is shown on the model. Mandibulomaxillary fixation is done with a dental arch bar wired to the lower jaw. The arch bar is cut to length. Wiring starts from the stable portion of the mandible. The arch bar is passed between the wire ends and secured to the teeth. Each tooth should be ligated to the dental arch bar. The comminuted side is wired to the arch bar in the same manner. Each fragment should be fixed with at least one wire. To establish dental occlusion, Ernst ligatures are used in the maxilla. There are various types of arch bars, although the applications are similar. It is critical to recreate normal occlusion before fixation. The arch bar may be covered with acrylic to increase stability. The instruments needed for the adaptation plate are the plate cutters, 2 plate benders, the 1.5 mm drill bit with 6 mm stop, and the 1.5 2.0 self-holding cruciform screwdriver shaft with handle. The comminuted zone can be simplified by using plates to reduce the smaller fragments into one large fragment. A 2.0 adaptation plate can be cut and contoured, although in certain cases, smaller plates or lag screws can be used. 1.5 mm monocortical drilling and 2 mm screw insertion are done in the usual manner. These plates are used only to align the fragments. Screws should not be inserted too close to the fracture lines. To bridge the comminuted area, a 12-hole 2.4 locking reconstruction plate is used. The plate has to be long enough for at least 3 holes to be used for anchoring on either side of the comminuted area. A bending template will make it easier to contour longer plates. If the plate needs trimming, the shortcut cutting device can be used. There are 3 steps to plate bending: in-plane bending, out-of-plane bending, and twisting the plate. The bending pliers with nose and the bending irons are used. Bending screws are inserted into the plate holes that later will be filled with locking screws. Without these bending screws, the holes become deformed, and the locking screws can no longer be guaranteed to fit accurately. The bending pliers with nose are used to bend the plate in 2 planes. In the first step, the plate must be bent in plane. The opening marked Bend First is used. The plate must always be bent between the plate holes. The plate is gradually guided through the opening according to the curvature required. For contouring in the opposite direction, the plate must be turned. The curvature is checked against the template. In the second step, the plate is bent out of plane. The plate is inserted into the opening marked Bend Second. The end of the plate can be bent using the nose of the pliers. The procedure is completed with the plate being twisted. The plate is inserted into the vertical openings of the bending irons, which then are rotated against each other. The plate is checked against the template. As an alternative, the first 2 steps can be done with the bending irons. For in-plane contouring, these openings are used. The best way is to position the bending irons opposite each other. Bending out of plane is carried out using these openings. After bending is finished, the bending screws are removed. These are the instruments to apply the plate: the holding forceps with ball tip, the 1.8 drill sleeve with thread, the 1.8 millimeter drill bit, the depth gauge, the 2.4 cruciform screwdriver with holding sleeve, and the 2.4 1.8 double drill guide. The plate is fixed to the model using the holding forceps. To guarantee precise axially centered drilling and later an accurate fit of the locking screw in the plate hole, a 1.8 drill guide with thread is screwed into the plate hole. The 1.8 millimeter drill bit is used to drill the bicortical hole. The drill guide is removed and the length is measured. The appropriate 2.4 millimeter locking screw is inserted. The second locking screw is inserted into the other end of the plate. The forceps is removed. At least 3 screws are placed on each side of the comminuted area. In addition, large bone fragments in the comminuted area can be secured to the plate. Here, a conventional 2.4 millimeter Cortex screw is used for this purpose. The large fragment is reduced, and the drilling is done with the 1.8 millimeter drill bit through its drill guide. After measuring the depth, the appropriate 2.4 millimeter screw is inserted. Another screw can be inserted if needed. With the 2.4 locking reconstruction plate in place, the fracture is now functionally stable. The locking plate bridges the comminuted area. It's important to note that no form of compression has been applied. The result of the procedure is shown in the clinical picture and the post-operative radiograph. This exercise has illustrated the basic principles of the locking reconstruction plate. Application of the supporting adaptation plates and the reconstruction plate has also been shown.